Alright, this is the 4.7a worksheet homework. Number 1, they're asking you to use the quadratic formula to solve the equation. So it might help us if we remember the quadratic formula. So if we write it out up here, it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So when we're going to use that in order to solve this, we can look at this equation, see that our a is 1, our b is -4, and our c is 3. So we're going to go in and we're going to substitute those values into the quadratic formula. When you substitute, make sure you use parentheses. So the opposite of b plus or minus the square root b squared minus 4ac all divided by 2a. So you see that I used parentheses whenever I substituted. Now you want to simplify. The opposite of -4 is +4 plus or minus the square root. -4 squared is 16 minus 4 times 1 times 3 is 12. So 16 minus 12 is 4. And the denominator, we have 2 times 1 is 2. Now because we know the square root of 4 is 2, we can write down 2 here. So 4 plus or minus 2 divided by 2. This is going to give us two solutions. 4 plus 2 is 6, divided by 2 is 3. 4 minus 2 is 2, 2 divided by 2 is 1. So our solution set is 1 and 3. Alright, this one over here, we're going to be using the quadratic formula again. So you can write that out. Let's find out what our a, b, and c values are. So let's write this in order. So we want to write the 9x squared term first, then the 12x, and then we need to move this 5 over to the left. So minus 5 equals 0. That means our a value is 9, our b value is 12, and our c value is -5. So the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So let's simplify this. So we have the opposite of 12 is -12 plus or minus the square root. 12 squared is 144 minus 4 times 9 is 36. 36 times 5 is 180. So what we have here is it's minus -180. So it's going to be plus 180. What I typically do is I check to see, because I know I'm going to be multiplying all these terms together, I check to see what my sign is going to be. So a negative times a positive times a negative is a positive. So 144 plus 180 is 324. So that's what's going to be inside. Then we have 2 times 9 is 18. So the square root of 324 is 18. So we have -12 plus or minus 18 divided by 18. So that's going to give us two solutions. -12 plus 18 is 6. 6 divided by 18 is 1/3. Negative 12 minus 18 is negative 30. Negative 30 divided by 18, you can do that out over here if you want. Negative 30 divided by 18. You see that 6 goes into both of these. 6 goes into 35 times, and it goes into 18 3 times. So we have negative 5/3. So our solution set is negative 5/3 and 1/3. Alright, number 3. They're asking you to evaluate the discriminant. Recall that the discriminant is the same as b squared minus 4ac. It's whatever's inside the square root in the quadratic formula. So first we need to find out where our a, b's, and c's. So what we're going to do is we're going to move everything to the left-hand side. So let's move this term over. So it's 3x squared plus x plus 2 equals 0. That means our a is 3, our b is 1, and our c is 2. So all we have to do is find out what b squared minus 4 times a times c is. 1 squared is 1, minus 4 times 3 times 2 is 24. So we get negative 23. So negative 23 is the discriminant. So the discriminant, negative 23. The number of real solutions is 0. There's no real solutions. If the discriminant is less than 0, it's not going to have any real solutions. So let me just write out the rule over here in case you didn't get it during class. So if the discriminant is greater than 0, you'll have 2 real solutions. If the discriminant equals 0, you're going to have 1 real solution. It's going to be a double root. If the discriminant is less than 0, you're going to have 0 real solutions. Alright, this one says solve using any method. So what we're going to do is, let's practice the quadratic formula. So let's write it out first. Let's get this in standard form. So 4x squared plus 4x minus 3 equals 0. Let's identify our a, b, and c values and then substitute it in. So the opposite of b, plus or minus square root of b squared minus 4ac, all divided by 2a. So let's simplify this. The opposite of 4 is negative 4, plus or minus a square root. So you see over here we have a negative times a positive times a negative. So we're going to have a plus. So 4 squared is 16, plus 4 times 4 times 3 is 48. You could have looked at it as negative 4 times 4 is negative 16. Negative 16 times negative 3 is positive 48. So that's going to be 64. Divided by 2 times 4 is 8. So the square root of 64 is 8, so we can write that down. So we're going to have 2 solutions here. Negative 4 plus 8 is 4. 4 divided by 8 is 1/2. Negative 4 minus 8 is negative 12. Negative 12 divided by 8, you can write it out here. 4 goes into both of those. it's negative 3/2. So our solutions are negative 3/2 and 1/2. Okay, this is another one where you can solve using any method you want. Let's just write it in standard form first. Move the 6x over, move the 11 over, so you have minus 11. For this one over here, I'm going to use the calculator, just to use something different. Alright, get this calculator out here. Alright. So let's turn it on. Y equals, we'll do x squared plus 6x minus 11. You can graph it. And we see that our zeros are here and here. So let's find them. So second trace 2. Left bound, we're going to keep scrolling till we see it. There it is. It's right here. So as we're going from left to right, the area above it is going to be the left bound. The right bound just under. And then we can guess. So over here it's going to be negative 7.47. That's our first solution. So let's write that down. Negative 7.47. That's our first solution. Let's get the calculator back. Second trace 2. I'm going to keep scrolling till we see it just underneath. Right here, that's the left bound. Right bound just after. And then guess. 1.47. So if we wanted to know the exact solutions for this, what we could do is we could either complete the square or use the quadratic formula to get what it equaled. We just estimated over here. Alright, here's a little challenging problem. They want us to write a quadratic equation with the given solutions. So if you recall before, if we were given a problem like this, for example, if our solutions were negative 1 and 2, what we would have done was we would have put 2 sets of parentheses. We would have said x minus negative 1, so x plus 1, and then x minus 2. And then we would have FOILed this out to get our quadratic. It's the same exact thing. So what we're going to do is we're going to do x. This isn't part of the problem. So we're going to have x minus this stuff. Sorry, I forgot that there was a denominator there. So if you recall, this denominator is the coefficient of x. It's 2x. And then we said minus all of this stuff. That's going to be our first set of parentheses. The second set of parentheses, this is the coefficient of x, 2x, and then minus the numerator. So 3 minus root 5. And I could have shown that here. For example, if this was negative 1/3, the 3 would have been in front of the x here. It would have been 3x plus 1. So remember, the denominator is the coefficient of x, and then you take the opposite sign, so minus 3 plus root 5. And because the numerator is a binomial, you have to put this in parentheses. So what I would do now is distribute the sign into the parentheses. So we have 2x minus 3 minus root 5. Then over here, 2x minus 3 plus root 5 equals the function. So what we can do now, because we have 3 terms times 3 terms, we can distribute this term into all three terms over here. So 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. 2x times root 5 is 2 root 5x. Now we do that with the negative 3. So negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. Negative 3 times positive root 5 is negative 3 root 5. Then finally we do it with the negative root 5. So negative root 5 times 2x is negative 2 root 5x. Negative root 5 times negative 3 is positive 3 root 5. Negative root 5 times positive root 5 is negative 5. Because root 5 times root 5 is root 25. The square root of 25 is 5. So that's a lot of terms here. But you'll notice there's a lot that we can cancel out. The positive 3 root 5 minus 3 root 5. That cancels. The negative 2 root 5x and the positive 2 root 5x. Those cancel. Then we're just left with regular stuff. So 4x squared. We have a negative 6x and a negative 6x. That's negative 12x. And then 9 minus 5 is 4. And that can be your function. So this is an example where if you were to solve for the solutions, you would get the two solutions that we started with. You could divide all of these by a factor of 4. So you could have x squared minus 3x plus 1 equals f of x. That's another possibility too. You could divide all these by 2. You could have 2x squared minus 6x plus 2 equals f of x. All these three are perfectly fine. Alright, so a review problem. Solve by completing the square. So let's start by writing it down. First step, move the constant term over. Now I'm going to think ahead. I don't have a greatest common factor here that I have to factor out. So I'm going to leave a space right off the bat. So I'm going to take half of this term, negative 3 halves, and I'm going to square it. So that's 9 fourths. And I'm going to add 9 fourths to the right hand side. I'm going to simplify the left hand side. Square root of this, take that sign, square root of that, equals. If I get common denominators here, this is going to be 32 fourths. 32 plus 9 is 41. So I'm going to have 41 fourths. Now I'm going to take the square root of both sides. And then I'm going to add 3 halves over. And at this point, this is perfectly fine for you to write down as an answer. Alright, number 8. Find the equation in standard form of the line parallel to that line passing through that point. So what we can do is look at this line. This is the slope of that line. We want a line parallel to that. That means the slope of the line parallel to this is going to be exactly the same slope, because parallel lines share the same slope. And we also have a point that this new line is going to go through, 3, negative 1. So what we're going to do is we're going to start with point slope form. So y minus y1, so y plus 1 equals the slope times x minus x1. So that's the answer in point slope form, but they want it in standard form. That means they want it in ax plus by equals c. That means what I'm going to do is I'm going to multiply both sides by 4. And the reason why I do that is to get rid of this fraction here. So I'm going to have 4y plus 4 equals, that gets rid of this, so x minus 3. Now what I'm going to do, if you look at the standard form here, the x's and y's are on one side. So I'm going to subtract x, I'm going to move this over, so I'm going to have negative x plus 4y equals, I'm going to move this 4 over, so I'm going to subtract 4 from negative 3 and I'm going to have negative 7. I'm almost done. Standard form, they want you to write the lead coefficient of x as a positive. So I'm just going to take both sides and divide it by a negative 1. So I have x minus 4y equals 7. And this is going to be your answer. Alright, number 9. What is the y-intercept of the quadratic function? So let's write down the function here. And remember that to find the y-intercept, it doesn't matter what kind of equation you have. Always set x equal to 0. So I'm going to do that here. And solve for y. That's the general rule. So y equals 0 plus 2 is 2. 2 squared is 4. 4 times 2 is 8. And when you subtract 5 from 8, you have 3. So the y-intercept is going to be 3. So again, set x equal to 0 and solve for y. Alright, number 10. Snapper Slim Sandwich. Apparently they only used one slice of bologna, because it wouldn't have been a slim sandwich if they used 10 slices, because that would have been a snapper fat sandwich. Slim sandwich, 1 slice of meat. Fat sandwich, 10 slices of meat, which is also called gross sandwich. Anyway, so this guy, let's call him Snapper, incorrectly concludes that because two discriminants are equal, the solutions of the two equations are the same. Write out an explanation of his error. So what Snapper's doing, he's saying because the discriminants are the same, let's call the first discriminant x and the second discriminant x. Because the discriminants are the same, the two equations, or the two solutions are the same. What is he saying? Well, we have to recall that when we're talking about discriminants, we're talking about the inside of the quadratic formula. So he's saying because this is the same as another one, the two solutions have to be the same. Well, he's obviously wrong, because just because the inside of the square root is the same as another example doesn't mean you're going to have the same thing. Here's an example of what I'm talking about. Let's say we have 10 plus or minus the square root of 4 over 1. And then we had another example. Let's say example 1. And then example 2. We'll have 2 plus or minus root 4 divided by 15. What Snapper is thinking is because the discriminants are the same, oh, this one has 4 and that one has 4, therefore the solutions are the same. He's obviously wrong, because look at the solutions on this one. 10 plus 2 divided by 1 is 12. 10 minus 2 divided by 1 is 8. Those are the solutions to that example. What about this one? 2 plus 2 over 15 is 4/15. 2 minus 2 over 15 is 0. He's wrong. Look at the solutions. They're completely different. Just because the discriminants are equal doesn't mean that the solutions are the same. Because the solutions aren't only dependent upon the discriminant. It's also dependent upon what this is and what this is. So if B and A are different on two different quadratics, then there's a chance that you could have the discriminants be the same. But if B and A are different, you're not going to have the same solutions.